All right, guys. So everything that we've been learning since the first day of school has led us to this point. We are now starting to draw Bohr models, and Bohr models are a tool used to illustrate or draw the atomic structure of an element, and all elements have atomic structures. So there's a couple of things that you need. Obviously, there's a reason why we talked about the subatomic particles, your protons, neutrons, and electrons. There's a reason why we talked about where to find protons, neutrons, and electrons by looking at a periodic table, and also how to find the number of shells by looking at a period on the left-hand side, and also by looking for valence electrons on the upper part by looking at groups or families. So valence electrons are electrons found in the outer shell of a Bohr model. And that's going to be the last shell, the last circle, depending on how many circles it has. The last one that it has, that's going to be the outermost circle. And that is where you find your valence electrons. Now, elements that have the same number of valence electrons are going to have similar characteristics, such as how explosive or reactive it is, and also how stable it is. So how little it explodes or whatever it doesn't. So again, if they are found in the same group or family, which is again going up and down in columns or vertical, they're going to have similar characteristics. So there's specific steps that we use to draw Bohr models. And we're going to go over those steps right now. So the first step, what is it that you need to get started? You need a periodic table. You always need a periodic table. And there's one to my right. Number 2, and that's going to be to pick an element. For right now, we want to stick between 1 and 20. You don't need to do any of the bigger ones. Can you? Yes, you can. Once you learn how to do this, you're pretty much set to draw the remainder of them. But you want to stick between 1 and 20 for right now, because they're not going to ask you for any element bigger than Ca, which is calcium. So we're going to pick an element, and because Mr. Rodriguez likes a challenge, we're going to pick the last one on there, which is number 20. And we're going to get highlighted blue, or whatever blue that is. So again, we're going to do calcium. Next up, we have the next step, which is step 3. And step 3 is going to be to find the number of protons and electrons for that element. The good thing is that you should know how to find protons and electrons. And if you don't, it's right here. The atomic number, the number at the very top, is going to equal the number of protons and electrons. So if you ever need to find protons and electrons, all you got to do is look at the atomic number. But Mr. Rodriguez, I don't remember which the atomic number is. If you have a periodic table, you have that middle element that's enlarged that tells you everything because it is labeled. But then again, I label it here for you. So atomic number equals the number of protons and the number of electrons. And for this element, it has 20 protons, 20 electrons. And we always want to write everything down, just so we have everything clearly written for yourself so you don't get confused. Next up, we have step 4. And step 4 is going to ask you to find the number of neutrons. Now, for neutrons, it's a bit harder. So what you have to do is you have to subtract the atomic number from the atomic mass. But again, it's a good thing that we've been covering this. So you should have no problem answering this question. But Mr. Rodriguez, which one is the atomic mass? Again, we have that one up there that's labeled, but I labeled it here for you. It's going to be the number right underneath the atomic symbol. So for this one, it's 40. So atomic number minus atomic mass. So 20 minus the 40, that's going to give you 20. We don't have to round off because it's at 40.0. So 20 neutrons. Again, we want to write that up there. And you have different colors. Use different colors. It's always beneficial to use different colors to differentiate. Then we have step 5. So step 5 is we got to find the number of shells. So what do? We got to look at the period. And again, that's going to be on your left-hand side, which is this side. It's the side on this side. And it's going to be numbered from 1 to 7. So again, you'll see it written right now for periods. It's right there. And again, it ranges from 1 to 7, going from 1 all the way down to 7. And again, what that means is that each number represents the number of shells or energy levels, which are the circles around the nucleus, or the circle that contains the nucleus, which contains the protons and neutrons, has circles around it. This just tells you how many it has. I like to draw little lines underneath just to symbolize what each one of them means. So for 1, I'll draw 1 line. For 2, I'll draw 2 lines, so on and so forth. But remember that periods equal the number of shells. So for calcium, we know that it has 4 shells. It's on period 4, has 4 shells. So again, we write that down. And then we move on to step 6. And I forgot to change the width of my pen. Nonetheless, this is where we find the number of valence electrons. And it's always very important that we find the number of valence electrons. And you'll see why at the very end when we do draw them out, because sometimes it can be a little tricky. So to find valence electrons, we use the groups or families on top. And on here, I did mess up. I said going from right to left. It's actually from left to right. It goes from left at 1 all the way to right, which is number 18. So again, fix that on the notes, please. I can't fix it because it's already been recorded, but it'll be fixed on the notes. So again, we're starting with 1, 2. Those are the group numbers with 13, 14, 15, 16, 17, and 18. When you get to 13 through 18, you use the second number on there. So for 13, it has 3 valence electrons, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8 valence electrons. The only exception is going to be helium. That has 2 valence electrons because it has 2 electrons in total. And again, those are going to be your groups and families, and those just tell you the number of valence electrons. Keep in mind, everything in that column is going to have similar characteristics. They behave the same. So we know that this one is in group 2, so it has 2 valence electrons. So again, we write that down. So VE equals 2. And now, I think we're ready to draw a Bohr model. We might be ready. No, we're ready. We have everything we need. So drawing a Bohr model. Again, this is what we've been working towards. So now I just got to find the perfect color to highlight it. And I obviously picked the worst color because it is gray, but I've already made it the color and we move on. So the first step is draw a nucleus. You need the nucleus. That is where you contain your protons and your neutrons. And my circles are going to be horrible. The good thing is that this app does fix my circles. So P and N. P is going to be protons. We have 20. Neutrons is N, which is 20 as well. We're done with the nucleus. We just got to move on to the remainder. Next thing that we do is that we look for the shells. Again, horrible circles. Good thing this thing, and they just get worse as I get bigger and bigger on the circles. Good thing again that this thing fixes them. I went a little ahead on the steps and I didn't write them down. I'm about to write them down in just a second. So second step or second is again draw the energy shells or the orbitals. Oh, sorry. Actually add the protons and neutrons, then draw the energy shells or energy levels, which we have on there already. We have 4. The fourth is going to be to add the electrons. Again, you want to remember that only a certain amount of electrons fit per energy shell. So we'll get started with that in just a second. So again, that's always important to remember. You can only put a certain amount. You can't just add all 20 into the first shell or 10 to the first, 10 to the second, because you're going to leave 2 shells empty. So again, you want to write down how many electrons you have. And what I like to do is write it down on the side and then just subtract as I'm adding to the shells, just so I know how many I have left. So first shell is going to have 2. So 2 on the first shell. And again, minus 2. And I also like to put where they went. So shell or first shell. So I have 18 left and I have the second shell. The second shell holds 8. So I add the 8 on there. So I subtract 8 from the total that are left. And I put second on there because that's second shell. I have 10 left and I still have 2 shells left. I know that on the third shell I can fit up to 18. Do I have to add 18? No. This is why it's important that we find the number of valence electrons, because if I add all 10 to the third shell, which does fit them fine, I'm going to have a shell left with nothing, and that can't happen. So we add to the third shell. Again, they can fit up to 18. We only add 8. That way we have the 2 left. Something that I like to do and we should have done is start off at the end, put the 2 at the end, subtract them from the total of the 20, and then start with the first one. That way you work your way from the last one, which we already know has, because we can figure out the number of valence electrons, and then work our way from the first one to the second one to the third one. That way it's a bit less confusing. Either way, I mean, it can work either way, but I just like to do that. And the fifth is going to be you're done. You've drawn a Bohr model. And again, this works for every single Bohr model or every single element. So key to a perfect Bohr is to always, again, fill in the valence electrons. That way you don't get confused in the event that you don't have the total number that fit in the previous shell. And yeah, that's pretty much it. Highlight it. That's important.